Okay, this is exercise number 3. There's nothing fancy here. Exactly what we've been doing, similar triangles. So let me draw out your picture for you. You've got a building. We've got the ground running through here. And then we've got an angle of elevation. So we've got from here. Actually, it really doesn't matter where we start our angle. Okay, so but we know that this angle, let's see here, is 38.7 degrees. Okay. I also know that the distance over, so from here to the base of the building, is 100 meters. So that's not too hard to find. You can just measure the length away from a building. Question is how tall is the building? So here's what we're going to do. We're going to take a look at the unit circle. We're going to compare similar triangles. Now you might know some other ways of doing this, and that's fine if you're thinking about formulas, but I really want you to get out of this particular problem. I want you to understand how to use similar triangles. It'll make those formulas more clear for you. Okay, so here's what we've got. We've got on the unit circle, I'm just going to draw this in quadrant 1. Okay, so here's quadrant 1 of the unit circle set up here. Okay, so here's the circle, and now I'm going to draw an angle of 38.7 degrees. So our angle of 38, so this is 38.7 degrees on the unit circle. Okay, now the length of the hypotenuse here, because it's on the unit circle, let me put a circle there. The length of the hypotenuse is 1, because of course it's the unit circle. It has a radius of 1 unit. Now here comes the important part. And this is what makes all this stuff in trig work here with these right triangles. What I want to know, okay, is I want to know these other side lengths. Okay. Now, because I'm going to use them to compare to my green triangle over here on the left. Now I want you to also notice too, and I should have mentioned this before, this has created, I have inside here, I'll kind of make it thicker for you, I have created a right triangle, assuming that the building is completely vertical, and let's hope that it is. Okay, now over here I've also got a right triangle, and they are similar to one another, and here's how I know that. Okay, all the angles match up. This bottom angle over here is the same as this bottom angle over here. They both share the same right angle, and since those two angles are already fixed, we know that those third angles are equal to one another. Okay, so here comes the interesting part. I'm going to use my calculator to get this length over here and to get this length down here. Now, how am I going to do it? Well, I know that the height, so this point right here has coordinates. Its x value is the cosine of 38.7, and its y value is the sine of 38.7. So I'm just going to take my calculator, make sure that I'm in degrees, because that's what I'm working in right now, and I'm going to first find the cosine of 38.7. So that gives me 0.78, and I'm going to round this, okay? So that means since cosine, okay, so let's just write this right below here. So that says that this is 0.78. So that means that this length down here, since this is the x value, this down here is also the x value, that this is 0.78. Now what's the height? Well, we just take the sine of 38.7, and we're going to get 0.62, I'm going to go all the way up to 0.625. 0.625. it's your decision on where you want to round to. Now, if the textbook or myself or whatever, whoever tells you where to round to, then go ahead and do it that way. Otherwise, use your best judgment. The further out in decimal places you go, the more accurate your answer will be. So our height is 0.625. So let me redraw this triangle over here. I'll do it in purple. So here's what I've got. Actually, I'll redraw both of them. I got a small triangle who has a length here of 0.78, a length over here of 0.625, and a length here of 1. That's based off of the unit circle. Then I've got a triangle over here in the green. That's the building one. Okay, it's a lot bigger, obviously. It has a length down here of 100, and we don't know what this length is, and that's what we're looking for. So now I just have to set up my similar triangles with my ratios. So everything's fairly simple here. So I'm going to go 100 divided by 0.78. So I'm going to take this side and divide it by this, and that's going to be equal to the question mark. Let's call it x. X, so this side length over this side length, 0.625. Now all I got to do is do a little bit of cross multiplying here. So 100 times 0.625 is 62.5. 0.78 times x is 0.78x. So we're going to divide both sides by 0.78. So we'll take 62.5. I'll write it out here for you. And that tells me that x then is equal to, let's see here, 80. So what is x? X is the height of the building. So the height is going to be equal to approximately 80 meters. So what we've done is we've figured out the height of a building just based off of how far away we were from the building and what our angle of elevation is. And I'm introducing a new term there, but whenever you're looking upward, so this angle is called an angle of elevation. You'll come across that term often in trigonometry. Okay, there we go.